I'm Anil Kumar, and now let us discuss characteristics of the given relation. The question here is determine whether each relation is a function or not and list their characteristics including domain range and behavior, increasing, decreasing intervals, symmetry, etc. Part E of the question we started with, which had 6 parts. We're almost at the end. Xy equals to 1 is the equation. Now, is it a function? We can rearrange and write down what y is equals to. So y is equals to 1 over x. 1 over x we know is a function. It is a reciprocal function. Let me sketch it for you. So you can look into my list of parent functions to know more about the reciprocal function and how to really sketch it. Now let us discuss about this function. Now we know if we draw a vertical line, it only intersects at one point. Therefore, it is a function. So we know it is a function, right? So that is the first part. Now let us list few characteristics of this particular function. Now starting with domain, we know domain for the function is x belongs to real numbers where x is not equal to 0. As far as range is concerned, y belongs to real numbers. Y is also not equal to 0. As you can see, y is not equal to 0. So we have a horizontal asymptote here. So we have a horizontal asymptote which is y equals to 0, and we also have a vertical asymptote which is x equals to 0. So that is the vertical asymptote, the y-axis. As far as symmetry is concerned, we know it has odd symmetry. Now let me explain what is odd symmetry. Odd symmetry is when f of minus x is equals to minus of fx, right? So we can actually algebraically prove it. F of x is 1 over x. We know f of x for the given function is 1 over x. F of minus x will be equal to, we have to replace x with minus x, and that gives us minus of 1 over x or minus of f of x. So you see f of x is minus of f of x, and therefore it has odd symmetry. Odd symmetry means it is symmetric about the point origin, right? So it has rotational symmetry. So this is symmetric about origin. We say it as rotational symmetry. So that is another way of writing the symmetry of this particular function, right? Now increasing, decreasing intervals, you see it is decreasing all throughout. So it has a decreasing interval. Remember, when you write decreasing interval, do not include 0. It is from minus infinity to 0, not including, right? Union, you can say 0 to plus infinity. 0 is not in the domain of this particular function. So these are the characteristics which you could write. As far as end behavior is concerned, let me write end behavior also here. End behavior defines horizontal asymptote here. When x approaches negative infinity, right this side, y approaches 0, right? So it is approaching a value, and therefore we have a horizontal asymptote. And when x approaches positive infinity, y again approaches 0. Maybe from positive side. Sometimes we write positive and negative, saying that when x approaches negative infinity, y approaches 0 from the negative side, and when x approaches positive infinity, right, then y approaches 0 from the positive side. So that helps to sketch a graph. So go through these, understand the terms, and I hope with this you can make a good beginning to advanced functions. Thank you and all the best.